So let us see on how we can be able to balance the chemical equation. Now let's say we have the equation given as, let's say, H2, and let's say we have plus, and that should be Br. We have Br2, that is bromine, that which is equal to HBr. That should be that case. So how should we be able to balance this actually a reaction if this is the case? You should have to understand that whenever we are balancing the chemical actually equation, the essence behind is that we should have we should have the same number of atoms in the actual reactant side as the same as in the product side. In other words, for this case, the number of hydrogen in the reactant side should also be the same as the number of hydrogen atoms in the product side. As you can see here, we have 2 hydrogen atoms in the actually reactant side, and we have only the single hydrogen atom in the product side. And also in the same case, we have 2 atoms of Br in the reactant side, and we have the only one actual atom of Br in the product side. So hence the reaction is not balanced. So now how should we balance the reaction? So now the essence behind is that we should not have to tamper with the superscripts. Whenever we are balancing the reaction, we do not really tamper with the superscripts. Hence, we work out with the stoichiometry coefficients. So what is a stoichiometry coefficient, or what is a coefficient? For instance, let's say we have x. What is the coefficient of this x? The coefficient of this x is given as 1. So which means having x, it is the same as having 1x, because in that case 1 is said to be a silent. Now let's say we have 2x. So in this case, this is the coefficient of x. And let's say we have, it should be, let's say 5m. So in this case, this is the coefficient of m. So that's what you call about what that's what you have to understand about the coefficients. So what are the stoichiometry coefficients? So in this case, we have H2. So the stoichiometry coefficient, it is given as 1. In this case, we have Br2. The stoichiometry coefficient is given as 1. And we have HBr, whose stoichiometry coefficient is given as 1 as well. Those are the stoichiometry coefficients. So whenever we are balancing the chemical actual equation, we work out with the stoichiometry coefficients. So how should we have or deduce the stoichiometry coefficients? And of course, now we have 2 ways in which we can be able to balance the chemical equation. But the balancing itself deals with the stoichiometry coefficients. And what are those methods? We have what you call trial and error method, and we have what you call systematic method. And I wish I only go for the systematic methods. That's a systematic method. I only go with a systematic method, and of which the try and error method, I'll leave it for you, and I'll need the responses in the comment sections below. Now, how should you go about the systematic method of the balancing chemical equation? So here are the things you have to understand. First thing, highlight what are the terms in the actual equation. So we have a first term, a second term, and this is the third term. We can also have the equation with 5 or 6 terms based on the nature of the equation. We have the first term, second, as well as the third. The next, we indicate the stoichiometry coefficients in those terms. So let's say we'll have, let's say A, and let's say we'll have B, and let's say this is C. These are the stoichiometry coefficients I'm talking about. The next, we should have to see what are the elements in the reaction. So for this case, we have hydrogen. We have hydrogen. That is given as H. Now, how should we have to balance up the hydrogen? In other words, we start one by one. So in this case, how many hydrogen atoms are here? We only have the single atom, which is 1. So in this case, we'll have 1 times A, or have it as 1 times A, or have it as A. And we do not have any hydrogen atom here, or have it as that. So have equal to, now in this case we only have the single hydrogen atom. So have 1 times C, that will be given as C. So this is equation 1. Then we'll go for Br. That is bromine. Should be bromine or bromine, should be that. Now for that case, we'll have it as that. So now do we have a bromine here? We do not have that. And how about here? We have it, and we have 2 atoms of bromine. And times B, we'll have it as 2B. That which is equal to, in this case we only have the single bromine atom. So times C, we'll have it as C. Mind you, the stoichiometry coefficients is corresponding for all actually elements there. So in this case, this is equation number 2. Should be the equation number 2. So now we are done with the substance elements that are involved in the reaction. Then let's go on how we can be able to balance it. So initially, we just have to guess the value of the single unknown value. Let's say we can say let, that should be let, let's say A, let A being equal to, let's say, 2. So for this case, if A is equal to 2, it means for this equation we'll have C being equal to 2 as well, because we have A is equal to C. And on the same case, if C is equal to actually 2 using this equation, then it means we'll have 2B, that which is equal to actually 2. Now for this case, we'll have B being equal to 1. So these are the values of the stoichiometry coefficients. Then we just have to simply substitute them into the function. Hence we'll have, what is the value of A? We have it as 2. And H2, and plus, what is the value of B? We have it as 1, or have it as a silent. We want to indicate 1 there. We will not have to indicate 1 there. And that is, what is the C? We have it as 2. We have HB, as you can see. So in this case, so we wrongly coded it here. And we should have, because 2 times A, we have it as 2A. So here should be given as 2A for hydrogen. So which means we'll have this actually equation that will be given as that. Of course, this is okay. Then let me take it back. A is equal, let's say A is equal to actually a 2. Then if A is equal to 2, it means we'll have C. We'll have C, that will be given as 4. Then we'll have C, that will be given as 4. By the way, you should have that. Sorry for that actually case. We'll have actually C is equal to 4. That is because if A is equal to actually 2, that means we'll have 2 times 2, that will be given as 4. It means C will be given as 4. Of course, you may think of having A is equal to 1, it is okay as well. Even if C is equal to 2, it is okay as well, but just that. So if C is equal to 4, then it means we'll be able to have the value of, let's say, should be the value of B. So for that case, if we have, let's say, 4 here, that should be like this. Let's say if we have C being given as 4 there, it means we'll have B, that will be given as, and that should be 2. So which means B will be given as 2. Then I can be able to balance the reaction. And in that case, we'll have, what is the A? We have it as 2 here. And what is the B? We also have it as 2. So just have to simply substitute So it should be that. We will just have to simply substitute. We have B is equal to 2. So we can have 2 here. And what is the value of C? So we have C being given us, and that should be 4. So in this case, the equation is fully balanced because we have 4 atoms of hydrogen and also 4 atoms C, and we have 4 Br. We also have 4 Br here. So that's how we balance the chemical reaction using the systematic method. So just have to be very careful with the calculations because we may end up missing some stuff there. And these are the problems mainly students tend to come across with whenever they are dealing with, and that should be a maths problems. Now let's say we have this reaction, and say we have SH, and that should be, we have SH and a plus, and that should be O2. And giving out with should be SO2. So now, how should we be able to balance the reaction? So in this case, we have 1, 2, 3. We have 3 actually terms there. So which means we'll have, that should be the coefficients given as A, B, and we'll have C here, as you can see. The next we identify the actually elements that are involved in the reaction. We have S. Now in this case we have actually 8 atoms of S times A. We'll have it as 8A. And we do not have any here. We'll leave it like that. And which is equal to, we only have the single S there. So have 1 times C, that will be given as C. That is equation number 1. And I go for oxygen. So for that case, we only have 2 atoms of oxygen. So have 2 times B, that will be given as 2B. Is equal to, here also we have 2 times C, that will be given as 2C. So have that as equation number 2. So now we can just have to rate any actually unknown value to have the certain value. For that case, rate that we should have, let's say, rate should be, let's say, A being equal to, let's say, 1. So if A is equal to 1, it means we'll substitute there. We'll also have C, that will be given as 8. Because if we substitute 1 there, we'll have A times 1 equal to C. So in this case, C will be given as 8. So now, if we have C, it means B can easily be obtained. In that case, we'll have 2B is equal to, now we'll have 8 times 2, that will be given as 16. So have B is equal to 8. So for this case, which means we'll have, what is the value of A? Is given as 1. So 1 to indicate that one, it is assigned to have A is 8. And what is the B? We have it as 8 or 2. That is, and what is the C? We have C being given as 8. And we can have it as A or 2. Now you can see that the equation is really balanced, as you can see it here. So check it out. And how about if we have, let's say, this case? Let's say we have this reaction. Let's say we have NH, let's say 4, and let's say NO, let's say 3. And like that, and equivalent to, now have N2 should be N2 plus now H2O. So let's say that's the case. How should we be able to balance this actually equation? So we also have actually three terms here. We have 1, 2, 3. So those are the actual terms. Then I indicate the stoichiometry coefficients for those. So which means, let's say this is A, this is A, this is B, and say this is C. So we should have to determine what are the values of those actually coefficients. So next we should have to see the actually elements that are involved in the reaction. And those elements are determined, actually those elements are identified from the reactant side, because the same elements that are on the reactant side are the same in the product side. Because we cannot have, let's say an element that appears to the product side and without being in the reactant side. Hence, we should have to understand that the atoms involved are the same throughout the chemical reaction. If we have oxygen here, we also have the oxygen here. There's no loss of electrons, should be atoms in the chemical reaction. Hence, the chemical reaction obeys the laws of conservations. You should have to get that. So let's start with nitrogen. Should be N rather, should be nitrogen, which is as simplest as N. So we only have, in this case, we have 2 atoms of hydrogen, because we have here 1 and also here 1, and we have them as 2. So which means we'll have 2 times A, that will be given as 2A. So have it as 2A, because this is a single atom, this is also a single atom. Together they are 2. So we have 2 times A, and which is equal to, here we also have 2 active atoms. Now in this case, we'll have 2 times B, that will be given as 2B. And of course, this is the same as A is equal to B. This is equation 1. And let's go for the other case. And let's go for the hydrogen, and which is given as H. In this case, we only have 4 atoms of hydrogen times A, will have it as 4A, and which is equal to, we do not have the hydrogen here, we'll leave it like that. And in this case, we only have the 2 hydrogen atoms times C, will have it as 2C. And of course, this is the same as having it as, should be 2A is equal to C. This is equation number 2. That is equation number 2. Take it like that. Then I will have this as equation 2. Then I will go for, let's say, oxygen. And in this case, we only have 3 atoms of oxygen. In terms A, we'll have it as 3A. Now, which is equal to, in this case, we only have the single oxygen atom. Times C, we'll have it as, should be C. So this is equation number, should be 3. And I'll create some space here, and for the other stuffs. So now, as it stands here, we may think of having a certain value for unknown. Let's say we can have rate A, let's say, is equal to 1. It is okay. If A is equal to 1, it means if we have A here, or have B, that also been given as 1. So if A is equal to 1, in this case, we'll have C, that will be given as 2. It means C will be given as 2, because if we have 1 here, it means we'll have 2 times A. Should be 2 times 1, that will be given as 2, is equal to C. So that is, so I wrongly recorded this here we are supposed to have 2. So we are supposed to have 2 here, like that. So which means we'll have, now for the oxygen, we'll have 2A here. Now we should have 2A here. So that is. So now we'll have to, since we have the value of let's say C, it means now in this case this is okay, because we have all the actually a given should be a coefficients, that is A, B as the C. We have everything. Now this is greatly verified by the equation number, let's say 3, because since we have A, we'll have 2 times A, which is 1, is equal to what is the C? We have it as 2. So the equation is balanced. So it means the values we have obtained, they are really true. Then I'll just have to simply substitute the A for B as well as the C. You see that the equation will be balanced in that way. So that's how we can be able to balance the reactions using the systematic method, as you can see. So I'll leave the try and error method for you, and only I'll need these feedbacks in the comment sections below. So I'd like to see how perfect the method is. I will be able to tag up the method, but it is nice as well to work out with. Only that it needs much attention. So you come across that one at your own. I'll just need the feedbacks in the comment sections, how you are able to. Let's say this is the reaction. So in this case, we also have H2O here, and we have let's say we have it as this. Should be barium 2, the carbon, and the plus H2O. The giving out, and that should be barium, and the O2 should be OH2 outside, and the plus, and that should be CH4. So how should we be able to balance this reaction? So now principle remains the same. We'll have to indicate the stoichiometric coefficients, and for this we have 1, 2, 3, 4 terms you should have to know. So in this case, we'll have to introduce A here, and we'll have B here, C, and we'll have D. Then I should have to identify the elements involved, that is barium, carbon, hydrogen, as well as the oxygen. Those are the active elements that are involved in the reaction. So let's start with one by one. That is, let's start with barium. So now on the barium, we have 2 atoms of barium here, and the 2 times A will have it as 2A, and we do not have N there. That will be equal to, so in this case we only have the single barium atom. In this case we'll have it as C. That is given as equation 1. And I'll go for the other one, and I'll go for carbon. So on the carbon we have the single atom of carbon there. In terms A, we'll have it as A. which is equal to. So in this case, we only have the single carbon atom. So have it as times D, that is given as D. So this is equation number 2. So this is equation number 2. So let's take it up. Let's take it up here. And we'll go for the other one. That is, let's say, hydrogen. How about on the hydrogen? We have 2 hydrogen atoms there. So hence, so in this case, we'll have it as 2b. That is equal to. Now for this case, you can see that O as well as the H, they're in the brackets with a superscript 2 outside, and that corresponds to have it as O2 H2. That is the same as that, only that since these subscripts are the same, it means it is okay to factor them out. So that's how they are here. But what it means is that it is the same as this. Then what it does is that we have, in this case, we have 2 actual hydrogen atoms. So it means we have 2 times actual C, that will be given as C, 2C. Then for this case, we have 4 hydrogen atoms, we'll have plus, now 4D. This is equation number 3. Then we'll take it up. That will correspond to have it as that. Then we'll go for oxygen. And then for this case, we have only a single oxygen atom. In that times B, we'll have it as B, that which is equal to. Then in this case, we only have the 2 oxygen atoms, so which means we'll have 2 times C, that will be given as 2C. This is equation number 4, and of which you also take it up as well. So we'll have that understand. Then we'll think of having the certain unknown to have its value. Let's say we have, let's say A being equal to 1. So in this case, if A is equal to 1, it means C will be given as, should be 2, because we'll have to substitute for A here, we'll be able to solve for C, that will be given as 2. And if A is equal to 1, it means D is also equal to 1. So in this case, it means D will be given as 1. And also in the same case, since we have A, C as well as the D, then we can be able to solve B using this equation. So since we have the value of actually C, which is given as actually a 2, then B will be given as 4. Then the B will be given as, it should be 4. So you can see that we completed to have the unknown variables there. Despite that, we have not used this equation, but it is the same way you should have to get it. So keep that in mind. Then you can be able to substitute these in their respective positions. You'll be able to have everything as necessary. So you'll be able to substitute everything there. So that's how we balance the reactions using the systematic methods. So try to go for try and error method at your own time and appreciate. So you should have to try the following problems and be able to practice. So you should have to balance the following reactions at your own time. Let's say we have CH4 and our plus should be O2. That is giving us CO2 and our plus H2O. So try that, and also try to balance this one out. That is HCl and that plus CaCO3 should be CO3, and the giving out, that is CaCl, and that should be 2, and plus, that is H2O, and that is plus CO2 as well. So try to balance that one out, and also try to balance this at your own time. Let's say we have, and that should be B4 O10, and the reacting with should be H2O, and the giving out H3 should be H3, BO should be 4. And I'll also try to balance this as well, where we have Al and the plus H2 should be SO4, and the giving out Al2, and that should be SO4. Now we have 3 outside, and our plus should be plus H2. So try to balance these cases. So that's how we balance the chemical activity equations using the systematic method. So this knowledge will help you to understand about, this knowledge will help you to go for the reacting masses and also excess and limiting reagents cases. Thank you.